Okay, so let's talk about question number 1. In question number 1, a solution of 9.23 grams of a non-volatile, non-dissociating compound in 694 gram of benzene freezes at 2.39 degrees Celsius. So what does this mean? This 9.23 grams is the solute, 694 gram is the solvent. The question is calculate the molar mass of the unknown, means find the molar mass of your solute. The melting point of pure benzene, which is a solvent, is given and the Kf value is given. In the freezing point depression video, which is labeled as colligative properties, we saw that when you add an unknown solute, the freezing point decreases. The freezing point of the pure solvent decreases. I discussed this formula, T solution equals T solvent minus delta Tf. And so delta Tf is basically T solvent minus T solution. I am given the T solvent value here. I am given the T solution value here. Using that, I can find out delta Tf, which is step number 1. Step number 2, I can use the formula delta Tf equals Kf times m to find the value of molality. Kf is the freezing point depression constant and the value is given here. Once I have the molality value, molality is moles of solute divided by kilogram of solvent. I have molality value. I know the mass of the solvent in grams. I can change it to the kilograms, put it here and find out moles of the solute. And final step, moles of the solute. Basically moles is what? Moles is grams over molar mass. I know the moles of solute. The gram mass of the solute is given here, 9.23. I can find out the molar mass of the compound. Question number 2, you have to find the freezing point of a solution. We know that delta Tf is equal to Kf times molality. And what is delta Tf? It is the change in temperature, which is the freezing point of the solvent minus freezing point of the solution. And that will be equal to Kf times molality. And what is molality? Molality is moles. Molality is moles of the solute divided by kilograms of solvent. And moles, what are moles? Moles is grams over molar mass. So I am replacing this moles on the top with gram over molar mass divided by mass of the solvent in kilograms. So basically in this question I am trying, instead of breaking it down into 3 or 4 steps, I am writing everything in one step. So what do I have to find out? I have to find out the freezing point of a solution. That means this is what I have to find out. Am I given the freezing point of the solvent? Yes, my solvent is camphor and this is the freezing point of the solvent. Kf is also given here. Grams of the solute is here, 3.24 grams. Now molar mass, do I know the molar mass of my solute? I'm given the formula. Using the formula I can find out the molar mass, that will go here. And kilogram of solvent, my solvent mass is 20.62 grams and I can change that to kilograms. So I know all these values, T solvent, Kf, grams of solute, molar mass of the solute I can find with the formula, change the grams of solvent to kilograms to find T solution. Question number 3, when 3.24 grams of para-dichlorobenzene was dissolved in 15.40 grams of benzene. This tells me that para-dichlorobenzene is my solute and benzene is the solvent. And you can find the formula for para-dichlorobenzene. It's right here in question number 2. The question is, the given is the solution froze at negative 1.78 degrees Celsius. The freezing point of pure benzene is 5.41 degrees Celsius. Calculate the Kf. Let's do the same thing. Try to do it in one step. Delta Tf equals Kf times molality. Delta Tf, change in temperature, is the freezing point of the solvent minus freezing point of the solution equals Kf times molality. Molality is moles over mass of the solvent in kilograms. And what are moles of the solute? Moles is grams over molar mass divided by the kilogram of solvent. So 3.24 grams of para-dichlorobenzene. So these 3.24, that is the grams of the solute. I can find out the molar mass of the solute using this formula. Then was dissolved in 15.40 grams of benzene. This is the mass of the solvent in grams. I can change it to kilograms. The solution froze at negative 1.78. So the solution froze. So this is T solution is negative 1.78. And the freezing point of pure benzene is 5.41. So I know the value of T solvent, T solution, grams, molar mass, kilogram of solvent. I have to find out Kf. In question number 4, what I'm going to do is I am just going to write down my whole formula. You are given this here, Kf, grams of the solute and the solvent, they all are given, and you have to find out the molar mass. Question number 5. Which of the following liquids will have the lowest freezing point and why? If you look at A is pure water. When you have pure water, it's a solvent and its freezing point is 0 degrees Celsius, and there will be no change in the freezing point of pure water because we are not adding anything into it. So in this case, the freezing point will not change because no solvent has been added. Look at B. In B, you are adding 0.1 molar ferric iodide solution. Ferric iodide is an electrolyte. Why? Because it's an ionic compound. And ionic compounds break down into ions. So if you take ferric iodide, that means in the solution it is going to break down into one ferric ion and 3 equivalents of iodide ions. So basically adding 1 equivalent of ferric iodide means you are adding 4 equivalents. Remember, colligative properties does not depend on the identity of the compound. It depends on the concentration. It depends on how much you are adding. So when you, let's say you are adding 1 mole of ferric iodide in the pure solvent, you are basically adding 4 moles of something, because 1 mole of ferric ion and 3 moles of iodide ions. So here let's assume 1 molar, so you are basically adding total 4 moles. 1 mole of ferric ion, 3 moles of iodide ions. C, you are adding glucose. Glucose is a non-electrolyte non-electrolytes is a covalent compound, they do not break down to form the ion. So that means if you are adding, let's say, 1 molar, just to make it simpler I'm putting 1. If you are adding 1 mole of glucose, that means in the solution, since it's not breaking down, that means you basically still have 1 mole of glucose. D, you're putting sodium iodide solution. Sodium iodide is again an ionic compound. It will break down to produce Na plus and I minus. And that means adding 1 mole of sodium iodide basically means adding 2 moles of the ions. And again, keep in mind, we do not care what we are adding. What we care is how much we are adding. So more you add, more the freezing point will go down. So in this case, the highest number of moles you are adding at B. That means ferric iodide will cause the depression of the freezing point most, because you are adding most number of moles in this.